So today we are going to build a Sine Vise jaw, and what that's going to be is you can see the print that I've got here, and let me kind of display or show you, walk you through what the purpose of this vise jaw is. I've got one finished, and let me move around here so you can see it just a little bit better. So I've already got one setting in the vise, and if you can see what's going on here, we've got what looks to be a normal vise jaw, and so what we've got is we've got some dowel holes in here. We've got a dowel hole here, one in the middle, and then a set of 4 that run up at a radius across this back side. And so this vise jaw is 1 by 2 by 6. I've squared it up, and from there on out, I've set a series of holes in here just to give myself some options to make life just a little bit easier as just working through the shop. And so let me give you a example or a short walkthrough of what we've got going on here. If I can shift in, get this thing moved down just a little bit more. Okay, so I've got my vise jaw sitting here, and I need a couple of dowel pins with this, and these holes are 251 reamed holes. And so if I've got a part that's wider than 6 inches, I can just set a part on there and go. Otherwise, I could set my part on there like that on some parallels. So let's just say, for example, every one of these holes is spaced out 5 degrees. And so let's just say I wanted to set something at 5 degrees. Maybe I needed to mill off something off the top of something. I had a part that needed a little bit of milling, angle milling. So now I've got this vise jaw, so I don't have to come in and get an angle plate or anything. I can set my part on here, and let's just say we were going to use a part like this. I can clamp it in. Now tighten it up, and then now I've got something so I can come across here without having to tilt my head, do any of those things. I can just come in here and mill this out. So you can use this for various thicknesses. I've used some pretty short dowel pins, and you can set it to 0 degrees, 5 degrees, 10 degrees, and you can just keep shifting it over. If you need to use a shorter parallel, you can. So here's 10 degrees. I can mill off 10 degrees off the top of this to catch my angle. Now, what I've given you in the print is just some information to get you started. I've not given you all of the dimensions that you need to make this part, and the reason being is I want you to know how to make this part. So what I've done is I've provided you with a fair amount of information. Everything that you need to do this part is provided here on the print. I've got my dimensions of 6 by 2 by 1. If you notice, those are 50 thousandths tolerance on those dimensions. Now, part of that is because what I want to use is just our 1 by 2 stock. We're going to cut it just a little bit longer than 6 inches. And we'll do a quick fly cut milling around the outside of that. I won't spend a lot of time on that. You've seen that before. Then we'll go into our counterboring our holes, and then we'll do our drilling and reaming of our angled holes here that follow through with these separate 5-degree increments. So that's our project today. The goal is to keep this thing under 2 hours, and we'll see what we can do. All right, let's get started. Okay, so I've got my stock sitting here. I've sawed it just a little bit longer than 6 inches. It is 2 inches by 1 inch by about 6 inches, 50 thousandths. So my normal standard process for squaring is going to start with this being my one side. I'm going to take this side first. After that, I'm gonna bring it up. I'm gonna mill the two side. But what I'm gonna do this time differently than what I would have done normally, or what I did in the last video, is when I do this side, I'm also gonna catch this side. So I'm gonna face across this face, and then I'm gonna bring an end mill in and catch this face here. So I'm gonna hit those two at the same time. Then I'm gonna rotate it up here. This will be my two face. So then after I move across to what would be this face, I'll come in here and I can do 3, and then I'm gonna catch this side here. So that way I've got this surface done, and then now I've got that. And so now I can come in here, put it in 2 vise jaws, hit my 4 side, and then I've already got 5 and 6 completed at the same time. So that's just giving me just another way to square something up, but then I can kind of shortcut a couple of steps through there. It's short enough that today my 1/2 inch end mill that I'm using has a flute length just a little bit longer than 1 inch. So I'm gonna be able to get all those all in one shot. Okay, so I've got my part set in. The vise, already have my head squared up, trimmed in, and I've got my vise squared up as well. I'm using our parallels that we ran from our previous project, and so I'm gonna come in, I'm gonna use those. I've already got those things kind of smacked down. Everything's in there nice and snug. I've got my quill nice and tight. So now I'm just ready to go ahead and set some speeds and feeds. So I'm not going to tell you RPM wise, so I'll tell you what material that I'm using. I've got some mild steel, some 1018 cold rolled steel, and then I've got just a cemented carbide on here, and so you do have that single tip carbide cutter for your fly cutter. So give me an RPM for that, and then we'll get going. So all we're going to do on this is just surface all 6 sides of this thing, but we also, when we're surfacing it, we do need to make sure that it's square. So when we put these holes in here at 0 degrees, 5 degrees, 10 degrees, and 15 degrees, we also are thinking about the fact that along the way throughout life, and as we use this jaw over and over and over again, we're going to add additional holes to it so that we can go to 20 degrees, 40 degrees, 22.5 degrees, whatever it might be. So after we do this, I want you to think about a way that you can mark out these holes with a letter number system, so that you'll be able to identify what hole is what along the way. All right, so we've got that face surfaced. I'm going to go ahead and switch over to a 1/2 inch end mill, and we'll mill this one single side of this, then we'll move on through getting the rest of the part squared up. And if you didn't see or haven't seen the squaring video, you want to backtrack through it, make sure that you know how to square a part up. I'll use most of those same processes today, other than side milling the edges. Everything else will stay the same. All right, so as we work up this side, we want to make sure that we're heading this direction on this face. We want to make sure that the tool, the cutter, is on the right-hand side of the material as it's going. So that's going to be our conventional milling. I'm using a Kennametal TE end mill. It's what's called the zombie mill, and carbide. I believe it is a 5 flute, 6 flute end mill, and so it's a really slick end mill. I'm super happy with it. I've been using it a lot lately. And if you're looking for a really good end mill, this is the number off of it. It's been really good for me. Again, I'm not going to give you speeds and feeds on that. There's a lot of variation for that, but if you're answering questions through this, then you know, there might be a speed and feed question for this. One thing I want to do whenever I'm side milling, I want to make sure that I'm locking down the axis of my table so that I don't end up with a potential to have that table start to run away from me. It happens pretty easily. So all I'm looking for is a cleanup cut on this side. All right, so now I have these two sides that are perpendicular to each other. Okay, so I've shifted everything around. I'm on a really short parallel. I've got my one side here. I've got my two side, or what's really my 5 or 6 side here. I've got a shorter parallel, or taller than the short parallel, but still a short parallel. It's helping to hold this dowel pin in. That side is an unmilled side. I'm going to mill my 2 side now, and then just keep going through the processes. Okay, so I've got my part squared up, and I've moved into, I've got it sitting on parallels, but I've just got it barely sitting on top of these parallels. I've got them in a spot where I can still move these parallels out, because as I finish my part, I'm not going to move it from this position for the rest of the time, but I am going to have to pull the parallels out at one point. And honestly, I could probably pull them out now. I think I'm going to probably wait until after I get my counterbore holes put in. My first process or next function or feature that I need to take care of right now is making sure that I've got this corner found. So I need to edge find this part, and I'm going to put X0, Y0 for right now in this lower left-hand corner. So I'm going to start my spindle up and go ahead and find the corner. Go ahead and move my table down, shift it over my 100 thousandths. verify that the center of my edge finder is truly spinning at the edge of my part, and it is. So I've got one more axis to do. Now here I can go ahead, I can either move the table up or the quill down. Got it wobbling. Come in here, bring it in, let the wobble stop, let it do a real gentle kickoff, and zero out. Bring my quill back up. Move up my 100 thousandths. And zero that out. Now I've got X and Y zeroed. If I want to double check that, I can go over here, 200. See that I'm spinning right on top of that corner, and I'm good to go. All right, from here, I'm gonna go ahead and shift over, and I'm going to move into spot drill. And as I start spot drilling my holes, I'm also going to change where my 0 point is. So even though I edge found there in that corner, I'm going to end up moving it over to the datum point on our print. I'll bring the print back up so we can see what it looks like, just as a reminder of where 0 is at. Because 0 is not really the lower left-hand corner of the part. It's really that that lower left-hand dowel hole is where a 0 is at. So I'll bring out the print, or bring back the print. Bring that in so you can see that. So we've got our print here. We're going to set our 0 in right here. Now our jaw is 6 inches. This is 2.5 from here. So the opposite of that would be 5. So that means that this corner must be up 500 thousandths and over 500 thousandths. So I move there for my first position for my hole, and I will reset 0 there, and then just start spot drilling holes as I go. I'll spot drill everything all in this one shot. Okay, move over here to 500 and 500. That'll be my first hole position. What I want to do is I'm going to take and just make a quick mark on that hole. So it's right here, and while I'm here, I'm going to go ahead and just real quickly take a scale and take some dimensions or mark out some spots. Just what I'm essentially doing is just doing a real quick layout for my part. So my hole up here goes over 1/4 of an inch. And it is up 1.25 inches from this hole. So it's really going to be about right here. So hole there. And then I have the center hole, which will be 2.5 over, and 437, 438 up from there. So about right there. And then I've got my opposite, or my angled holes that run up, and the first one same Y and then over 5 inches, and then we start to just move up as we go. So that should be 1.3, about there, just to give me kind of an idea of where these holes go. And then I've got my bore, or my counter bore hole spread, and that is 3.87. Then divide that by 2. Each hole should be 1.937. So we'll go to about here and about here. Just give me some ideas of where my holes should be. Okay, so I'm going to reset my 0 on my digital readout, and I'm going to start spot drilling holes. I want to drill these deep enough so that I've got a chamfer left over. So I will bring these holes to about 300 thousandths. So I'll go ahead and go up to my next hole, and we'll just hit that upper dowel hole. And so I'll go ahead and hit my center hole. Actually, I can go ahead and, yeah, I'll go ahead and hit my center hole next, just because it's on my mind. Okay, now I'll go ahead and go on over, hit my 2 counterboard holes. Say 1.935 from that edge. That's about right. Catch the second hole for the counter bore. Looks good. Now I'll go ahead and drop down. I'm gonna go down past it and then come back up so that I can get my Y in the same plane, meaning that I've got the same amount of tension or the same direction of tension on my screw. So in Y, I bring it up to 0. Okay, so that means that it'll be in the same plane as this hole here. Okay, I've got both of my holes now drilled. So just to catch you up, I've got everything spot drilled. I've drilled my clearance holes for my 1/2-13s. I've got my counterbore tool in there now. I'm gonna go back through those holes, counterbore those to depth. I use the book to figure out how deep that should go. Now, one thing I did is I switched down to low gear. This is only 2 flute, so similar to a drill, but it is taking a lot of material all at the same time. Where a drill has a taper in the front, this has just some flat areas. So we're gonna pile it down through this hole. We're gonna counterbore those 2 holes to depth, and then we can move into drilling and reaming our dowels. So you want to make sure your table's nice and tight when you're running this operation, locking down both X and Y. Also, cool tool is one of those places where this is one of those places where I'm going to use that. I want to try and keep as clean and dry as I can in the area that I'm working at, but this is a place where a cutting fluid, not just an oil, but a cutting oil, is really going to be super beneficial to chip control and longevity of that tool that you're using. First hole's done, move over to the second hole. Gets a good start in there. Now you'll notice this counterbore hole is really close to this dowel hole. It's okay. It's going to clear, it's going to be fine, but you do just kind of want to watch for those things as you go. A lot of times you can use a larger counterbore tool. In this situation, we couldn't. Say you didn't have the right size, but you had an end mill that you could use. You got to be pretty close on using an end mill here. You've got to use you can use a reground end mill, or maybe a metric end mill to bring it into size, but it's not a nominal fraction, so you're not going to be able to just grab any kind of end mill and use it. Okay, so those 2 holes are done, and so now all we have to do is jump in and start doing our holes for our reamers. All right, I'm gonna drill my holes for my reamers. I can lower the RPM way down on that. Switched back up into high gear, but I don't think I need quite that much RPM. Go ahead and slip my parallels out. Won't need those anymore. Should be pretty easy drilling for the rest of our time. Do want to make sure I'm continuously pulling that drill out, pulling it back, letting chips clear out. If you run into a little bit of trouble when you're drilling, you can absolutely use some cutting fluid. This is drilling pretty good, so I don't know that I'm going to need to. I may put a little bit in there just to kind of help it out as I go. But we're talking about some mild steel and talking about a pretty small diameter hole, so it shouldn't be too bad. But we can try it on this next hole and see if we see any kind of difference in it. So just put a little bit down in that hole. I think it drills just a little bit smoother as you use that cutting fluid. But you know, I think the important thing to remember is to not overuse it. Not only does it have some cost to it, but you're not trying to create a pool of oil at your machine. The amount of time that it takes to clean up your mess is also factored into the job that you're doing. So you want to pay attention to all those aspects that come into play. So I'm going to do my center hole now. That hole is at 2.5 from my datum hole. Past it just a little bit. And I am 438 from it, so I'll come up 438. Notice I'm coming from, I went down past it and then I'm coming back up. That way I can keep all that slack in the same direction. Three holes through. Going over to 5 inches. And then I'll go all the way down below 0 and then work my way back up to 0. Now you notice when I'm using my cutting fluid, I'm drilling just a little bit of a hole. That way I can get that in there and get that spot started. Have a little place for that oil to puddle up. most of the way through with my holes. Go on up to my next hole location. So here I can just keep going in this positive direction as long as I don't go beyond the hole location and Y. So I'm going to go up to my number. But now I've got to go back in X and then come back to it though. Going up to the third one. This hole's kind of like the second hole, really close to the edge. Okay, last operation, I'm gonna ream my holes. I've decreased my RPM, so I switched down into low gear. I'm gonna ream these out. I'm gonna use a little cutting fluid in each one of these holes. Now this reamer is a 251, so it's a oversized 1 inch or 1/1000th oversize for a 1/4 inch. So I feed it just a little harder through this. But much slower RPM. So I'm only taking about 10 to 15 thousandths out of this hole as I'm reaming it. So I've drilled it close, giving myself about 15 thousandths. That way I'm just bringing this thing to size. Positionally, I've already really positioned it when I spot drilled it and drilled it. So my reamer is just going back through, following that hole. That's why it's really important that even at spot drill position that I'm putting my hole in the right spot. Rarely does a hole get better as it goes. Typically you're going to find that hole starts to drift away as you go. So you want to make sure that even positioning at the spot drill level that you're getting those things in the right spots that they need to be. Now there is a hole to be out of position. It's really this hole. I'm definitely not trying to lobby for an out of position hole, but if there's one area to have a mistake on this part, it's probably here, because all we put this hole in for was an opportunity just to give ourselves a pin for a stop. So if we've got some parts set on parallels, we can just use that as just a real quick stop method. So now I'm going to go to my hole at 0, 0, and that'll be my last hole. That's it. Now all I have to do is take it out, deburr it, clean it up, and then do a quick QC on it.